Have you ever wondered what happens when a comet has a close encounter with a giant planet? Scientists recently discovered a comet named MAN, which is now speeding out of our solar system at an incredible 6,710 miles per hour after a dramatic meeting with Saturn. But how did Saturn's gravity alter the comet's path so drastically? What can we learn from this event about the dynamic processes with our solar system? The comet A117 UUD, which is now on a one-way journey out of our solar system following a close encounter with Saturn. This comet was discovered on June 14, 2024 by the Asteroid Terrestrial Impact Last Alert System. Despite being a recent discovery, researchers managed to use 142 observations to track back the comet's orbit around the Sun. This detailed analysis revealed that in 2022, A117 UUD had a significant meeting with Saturn, the second largest planet in our solar system, known for its bright and distinctive rings. This encounter with Saturn drastically altered the comet's path. The gravitational pull of the gas giant placed A117 UUD on a higher flattened or elliptical orbit. This new trajectory will eventually fling the comet into space beyond the Sun's influence. By using an advanced model to project the comet's future path, scientists found that A117 UUD will leave the solar system at a speed of approximately 6,710 miles per hour. To give a sense of how fast that is, it's about 4.5 times the top speed of a Lockheed Martin F-16 fighter jet. This event is quite significant because it marks only the second time scientists have observed a solar system comet in the process of being ejected into another space. The first such comet was Comet C 1980 E1 Bowell, which was set on an escape path from the solar system after an encounter with Jupiter on December 9, 1980. The researchers who studied Comet A117 UUD published their findings in the journal Research Notes of the AAS. They noted that the situation of A117 UUD is very similar to that of Comet C 1980 E1 Bowell, which suggests that A117 UUD did not come from another star system. Instead, it was originally part of our solar system. The fact that scientists have observed two such ejections in less than 45 years indicates that these events might be relatively common. When scientists first discovered the comet A117 UUD, it wasn't immediately obvious that it was a comet from our solar system that would eventually leave its home planetary system. Initially, the team studying this icy space rock thought its hyperbolic orbit might indicate that it was an intruder from another solar system. At first glance, the newly discovered comet A117 UUD appeared to be an interstellar object, which means it seemed to have come from outside our solar system. This wouldn't be the first time such a celestial body has visited us. In 2017, scientists detected another comet named Oumuamua, which is Hawaiian for scout or messenger. This comet was the first known interstellar object to pass through our solar system, and it puzzled scientists with its unusual shape and trajectory. Oumuamua was so strange that Harvard professor and theoretical astrophysicist Avi Loeb suggested it might be extraterrestrial in nature. Loeb's theory was based on the comet's ability to accelerate as it approached the Sun. He proposed that the Oumuamua could be using solar power like a light sail, much like a ship's sail catches the wind. This idea came from the fact that no natural phenomena seemed capable of explaining such space travel. Loeb, known for his theories about the interstellar origin of various objects, was eventually suggesting that Oumuamua might be an alien spaceship. 2 years after Oumuamua's discovery, in 2019, amateur astronomer Gennady Borisov discovered another interstellar comet named Comet 2I Borisov. This comet also originated from outside our solar system, adding to the growing list of interstellar visitors. Despite initial thoughts that A117 UUD might be another interstellar object, a team of researchers has now confirmed that it originated from within our own solar system. This comet has now been confirmed as the second solar system comet to be effectively launched out into interstellar space, making it an interstellar object in its own right. The first comet to undergo this transformation was Comet C 1980 E1 Bowell, which had a close encounter with Jupiter in 1980 and was ejected from the solar system. Another puzzling aspect of Oumuamua was its unexpected acceleration away from from the Sun. This led to some speculation that it might be an alien spacecraft, a claim that has since been mostly dismissed. Scientists eventually found an explanation for its unique behavior. They proposed that Oumuamua had been exposed to cosmic radiation for a long time before entering our solar system. This radiation caused hydrogen to be produced and trapped within the object's body. As Oumuamua approached the relative warmth of our solar system, the trapped hydrogen was released, creating a spray that propelled the object forward. Today, Oumuamua has moved beyond the orbit of Neptune and is passing through the Kuiper Belt, a region filled with icy bodies near the outer edge of our solar system. It's now out of reach of our telescopes and will never return to Earth or the Sun. The researchers concluded their study by noting the significance of these observations. They pointed out that the fact that two such ejections have been observed within less than 45 years suggests that these events might be relatively frequent. This insight helps scientists understand more about the dynamic processes at play within our solar system and the interactions that can send comets on interstellar journeys. However, Oumuamua isn't the only interstellar visitor we have observed. The second confirmed interstellar object was Comet 2L Borisov, discovered by amateur astronomer Gennady Borisov on August 30, 2019. 2I Borisov was identified as a comet, making it the first confirmed interstellar comet found within our solar system. 2I Borisov was traveling through our solar system at an astonishing speed of 110,000 miles per hour. To help you understand how fast that is, let's compare it to something more familiar. The speed of sound is about 767 miles per hour. So, 2I Borisov was moving 150 times faster than the speed of sound. To give another comparison, the top speed of a Lockheed Martin F-16 fighter jet is around 1,500 miles per hour. That means that 2I Borisov was traveling 75 times faster than this incredibly fast aircraft. Just like another famous interstellar object like Oumuamua, which passed through our solar system earlier, 2I Borisov didn't stay for long. It briefly fascinated both astronomers and the general public with its rapid journey. People all over the world were excited to learn about this visitor from another part of the galaxy. However, 2I Borisov was just passing through on its way out of our solar system, and it won't be coming back. Now, when we look at A117 UUD, this comet had a close encounter with Saturn, one of the gas giants in our solar system. The gravitational pull of Saturn was so strong that it changed the orbit of A117 UUD dramatically. Because of this encounter, scientists found it impossible to trace the comet's original path before it met Saturn. However, they were able to determine that A117 UUD was not another interstellar visitor like Oumuamua or 2I Borisov. Imagine this. Maybe in the distant future, millions or even billions of years from now, the comet A117 UUD, which was thrown out of our solar system by Saturn's gravity, might be discovered by astronomers from another civilization far away in the universe. These future astronomers could be as curious and excited about it as we are about 2I Borisov and Oumuamua today. By then, we humans might no longer be around, but our discoveries and the comets we found might continue to inspire others across the cosmos. In the end, scientists were able to trace back the comet's orbit and uncover its close encounter with Saturn, which drastically altered its path and sent it speeding out of the solar system. This rare event gives a glimpse into the cosmic dance of celestial bodies and the forces that shape their trajectories. Do you believe we might find more comets like A117 UUD in the future? Let us know your thoughts in the comments below.